All right, here's what I expect you to do. You're going to go in and you can measure these angles. Do you need to find all the angles? No. If you know that you're creating a regular polygon, then you just need to find one. I did the equilateral triangle and the square for you, but I'm going to talk you through how to construct a regular pentagon, and then you're going to construct all the other ones on your own. Okay? All right. So in order to construct a regular pentagon, what we're going to do is we're going to begin with a segment. This segment that we're going to start with represents one side of the isosceles triangle that we can create as a reference. Okay? So what I want you to do on this is we're going to take this segment that forms one side of the isosceles triangle that we're using as a reference, and we're going to rotate it to find where the second side of that isosceles triangle should go. In order to rotate it, you need to do a few steps. First, we need to determine which point we want the rotation to occur along. So if you right-click on the lower point, and then choose the command mark center, it should have like a pulsating bullseye that demonstrates that you've now marked that as your center. Okay. And then choose the segment that you want to rotate. So we're going to duplicate this segment and rotate it about that center point that we just determined. So when you select your segment and go up to transform, hit rotate, okay, we need to figure out how much of a rotation we need to make. Okay. And the reason I went through the notes first before this is, in a regular pentagon, what is that vertex angle of the reference triangle? Okay, now 108 is the measure of each interior angle. The vertex angle is equivalent to the exterior angle, so all you need to do to find this is take 360 divided by 5, and you get 72. Okay? So if we rotate this 72 degrees, you see where the new segment is. Okay? It's already designated as the same, or the correct center, so all you need to do is repeat this step, rotate it by 72 degrees, do it again, rotate 72 degrees, again, rotate 72 degrees, and you have all the sides of your isosceles triangle that you use as a reference. Okay, now the next step is important as well. Otherwise you might get measures that are off a tad bit. Okay, so these represent all the sides of the isosceles triangles that we're creating. So to create the actual figure, okay, we know that the figure is going to be inscribed within a circle. So let's create that circle. So go to the compass tool, place your cursor or the compass on the center point, extend it all the way to the point that you started with. You want to lock them together on that. Okay, once you lock it together, go ahead and choose the key to select the points, the arrow key. Oh, I'm sorry, the point tool. And you want to designate each point where the side and the circle intersect. So you need to make sure both are highlighted before you put the circle down, or the point down. So select when the circle and the segment are selected, so that there's no way to move these points without it moving the circle as well. Okay. Once you get all 5 of those points locked in place, what we can now do is we can go back and we can hide all the lengths that we used to create these points. So just all I did was I highlighted the center and all these sides of the isosceles triangles. I can also highlight the circle itself, hit Control H to hide everything, and I'll be left with just the vertices of that regular pentagon. And now if I select all of those points, so I can just drag and select all the points, hit Control L, it'll create my pentagon. So now as I move that one point that's tied to the radius or the original segment, I can move it in any direction, any distance, and our shape will remain a regular pentagon. Okay, and so now what you would do is measure one angle on that, and it would allow you to verify what each interior angle is. Okay, so when you look at a hexagon, first of all, the reason this worked was the rotation of our reference triangles, or the sides of our reference triangle, was 72 degrees. It's an integer. It's a whole number. Okay, is that going to be true for a hexagon? What's the rotation going to be on that first line for a hexagon? 360 divided by 6, does that give you a whole number? Yeah. So it'll work for a hexagon. What about a heptagon? 360 divided by 7? No, it's not a terminating decimal. As long as it's a terminating decimal, you could do it because it'll rotate that. But for a regular heptagon, it's going to be some measure that is like 54.13 something. I don't know what it was. But it continues. It's not going to map on as it rotates. So don't worry about the heptagon as far as illustrating it. You can erase that if you want. But what about an octagon? Is that one going to have a rotation that's a whole number? Or a terminating decimal? Yes. What about a nonagon? 360 divided by 9? Yes. What about 360 divided by 10? Yeah. So you can do all the other ones, just not the 7-sided regular polygon. And once again, when you're finished with this assignment, submit it, grade another for me. That's worked out really well. I appreciate all your help in getting that covered. There are a couple of you who have not gotten the full points on the 6.3, 6.4, or I'm sorry, the 6.4 notes yet. You may want to check and see what your score is on those, if you've submitted it or not. If not, I definitely get that done today. It's due by tomorrow morning, and really you don't have any other chance to use this program other than being here in class.